So the next type of reaction which we are taking up is on the basis of energy changes, that is the exothermic and the endothermic reaction, right. So as the name suggests, what does exo means? Exo means external and therm word means the heat changes, right. So whichever reaction leads to the release of energy comes under category the exothermic reaction, right. And any reaction which is accompanied by the absorption of energy is called as the endothermic reaction. Endo means internal, thermic means heat energy, right. So any reaction which is accompanied by the release of energy is exothermic, and any reaction which is accompanied by the absorption of energy means it needs the energy to occur, the reaction needs the energy to occur, is called as endothermic. So I am stating an example for you. The exothermic reaction, in your daily life you come across many reactions like combustion. What do you mean by combustion? Combustion means burning of anything, है ना? Like that means if you are burning an LPG, you are using an LPG at homes, you are burning it, what you are getting it? You are getting CO2, water vapor and heat and light. So that means it leads to the evolution of energy with the products. So that is why it comes under the category of exothermic reaction. And now we are considering the endothermic example. As we did, we can decompose CaCO3 by supplying heat. When we supply heat to this limestone, this calcium carbonate, it gets decomposed to its constituents CaO and CO2. So that means this reaction needed the energy, this reaction occurred due to absorption of energy. So therefore this reaction falls in the category of endothermic reaction. So that means according to the energy changes, we have the when the energy is absorbed or released, it is categorized into two categories, exothermic and endothermic. Moreover, we have few more reactions based on this energy changes that we have already discussed. The photochemical one, in which the energy is being supplied in the form of light. We did example AgCl when it breaks up to form Ag plus Cl2. So that is again a photochemical reaction. Similarly, you must be familiar with the term photosynthesis. What is it exactly? It is the process by which green plants make their food by utilizing CO2, water vapor in the presence of chlorophyll, by utilizing the sunlight, and they are just forming the food in the form of glucose, and plus CO2 is liberated. You know that, no? So what is happening in the photosynthesis? The compounds are getting they are just making the compound, and how they are making? Is photosynthesis possible in absence of light? No, it is not possible. That means the driving force which is making the reactants combine to form product, that is the CO2 and the water and this thing sunlight, chlorophyll, leads to formation of C6H12O6 glucose plus oxygen gas is evolved as a byproduct of photosynthesis. So what is the driving force that is making that reaction to happen? That is the energy, and in which form the energy they are taking? They are taking the energy in the form of sunlight. So that is also all the photochemical reactions are also based on the energy changes. So similarly, the reaction in which the electric current is being used, that also comes under the category of the energy changes. That means it is also based on the energy changes, because the energy, the form of energy which we are supplying is in the form of electric current. Again, we did in the previous units as well, in the previous topic as well, that we can supply energy in either form. The pressure, light, the heat, the catalyst, they all are the energy sources. So we have different categories on the basis of energy changes, that is the exothermic reactions, the endothermic reactions, the photochemical reaction, and the the reaction which are based on the electric current, that is the electrolytic reactions. So these all fall under the categories of the energy changes. They form the subcategory of the chemical reaction, that is the reactions which are based on the energy changes. And moreover, there it is the group that falls under the category of chemical reaction. So this is the all reactions we have done. We are just left with one kind of reaction, and you know that reaction is seen, you can see that reaction in the daily routine also. So what is the name of that reaction? Can you guess it? Which reaction we are left with? I hope no guess. So I will be telling you that kind of reaction, and just keep in mind that plays an important role. And what is the name of that reaction? It is the redox reaction. So what is it actually, the redox reaction? So before we proceed with the redox reaction, you should be familiar with the term oxidation and reduction. Now what is it exactly? What is oxidation and what is reduction? Right. So what is oxidation? Addition of oxygen to any substance or removal of hydrogen from any substance falls under the category of oxidation. See, I'll take an example for you to just make you clear. See, any reaction, suppose I take magnesium, right? So I'm adding oxygen to magnesium, what will happen? It will form magnesium oxide. So just look, on the reactant side, magnesium was all alone. It do not contain oxygen, but on product side now oxygen is being attached to it. That means oxygen is added to it. So whenever the addition of oxygen take place, it is called as oxidation, right? Similarly, we can use the second term, the removal of hydrogen. So suppose I have a sodium hydride, I am just doing any process so that the sodium and hydrogen get separated. So what happens? On reactant side, sodium is combined with hydrogen, and on the product side, sodium and hydrogen are separated from each other. So that means it is the removal of hydrogen, against it comes under the category of oxidation. So whenever the oxygen is added or the hydrogen is removed, it is said to be oxidation. And moreover, if we use, instead of oxygen hydrogen, if we are seeing that some other element is adding up or some other element is eliminated, then the reaction gets converted into the form that any reaction which leads to the addition of electronegative element and removal of electropositive element falls under the category of oxidation. Right. So oxidation is addition of oxygen or an electronegative element or removal of hydrogen or the removal of electropositive element is called as oxidation. Now coming to reduction, what do you mean by reduction? It is just reverse of the oxidation, right? It is the addition of hydrogen or an electropositive element, and or we can say it is removal of oxygen or a removal of any electronegative element. So that is also called as, that falls under the category of reduction. For example, see, I have sodium, I am adding hydrogen to it so that it should form sodium hydride. So what happens? Sodium is getting attached to the hydrogen. That means the reduction is taking place. Similarly, I have magnesium oxide, I am just heating it, or by any factor I am just making magnesium and oxygen separated from each other. So as we compare reactant and product, in product side oxygen is not present, that means oxygen has been removed, so that means it falls under the category of reduction. So this addition of oxygen or an electronegative element or a removal of hydrogen or an electropositive element or vice versa is just a classical concept to explain oxidation and reduction. It falls under the category of classical concept to explain oxidation and reduction, right? But we can define oxidation and reduction in terms of electronic concept as well. So whenever an element, whenever a substance loses electron, it is said to be oxidized. So all metals actually get oxidized. For example, we have sodium, it has got one electron in its outermost shell. To attain stability, it will be losing an electron. So we will say this sodium has lost one electron, so that means it is getting oxidized. So whenever an element is losing an electron, it is said to be oxidized. Similarly, for reduction on the basis of electronic concept, we say any element when gains electron, any element which gains or accept electron is said to be reduced. And which elements fall in this category? You know, non-metals are electron acceptors. So non-metals show maximum, they show reduction. For example, we have chlorine. So chlorine has 2H7, it will be gaining one electron to form Cl negative. So it has just gained an electron. So whether they lose one or two electrons or whether they gain one or two electrons, number of electrons hardly matters, doesn't matter at all. It is just the factor that whether they are losing or gaining. So when they are losing, it is said to be oxidation, and when they are gaining, it is said to be reduction. So I hope that you are clear with the electronic. This is the electronic concept, and above was the classical concept. So this is the classical and the electronic concept which clearly explains the oxidation and the reduction. Now you will be surprised to know that oxidation do not occur as such and reduction do not occur as such. Oxidation occur at the cost of reduction and reduction occur at the cost of oxidation. So in any reaction, if oxidation is taking place, so simultaneously reduction will be taking place, because if there is an element which loses oxygen, so there should be an element which accepts that oxygen, right? And similarly, when there is an element which needs an electron, so there should be an electron which can donate that electron. So that means oxidation and reduction both go hand in hand, right? So we have the oxidation and reduction, the reaction in which oxidation and reduction both occur simultaneously is called as redox reaction. See, as the name suggests, see, RED comes from reduction and OX comes from oxidation. The redox reaction is a reaction in which reduction and oxidation both are occurring simultaneously. So redox reaction just refer to this oxidation and reduction. It's a combination of oxidation and reduction. One more thing, there are two kinds of agent which are involved in this reaction. One is oxidizing agent and the other is reducing agent. Now what do we mean by this term oxidizing agent and reducing agent? What actually the agent is? What actually the agent is? Like if I say a traveling agent, what does a traveling agent do for you? Tell me. What he do for you? He just book your tickets. He is actually an agent. He just plan your tours. He just do the bookings in the hotels. So he is an agent for you who is doing that kind of work. If he is not present, it will be difficult for you to book hotels or plan tours like that. So that means this oxidizing agent, in the similar way, this oxidizing agent and reducing agent are playing that role. They act as an agent for oxidation or reduction, right? So what do you mean by oxidizing agent? Oxidizing agent is that which makes which oxidize the other substance and in return it gets reduced, right? It oxidize, I am repeating, it oxidize the other substance and itself gets reduced. In similar way, reducing agent, as the name suggests, will reduce other and itself gets oxidized. So in this case, suppose I am taking an example of redox reaction. We have CuO plus H2, so this forms Cu plus H2O. Now first step is to see that whether it is a redox reaction or it is not a redox reaction. See, this copper is attached with oxygen and on right side it is just deprived of oxygen. That means it has lost oxygen. That means reduction, any substance which is losing the oxygen is said to be reduced. So that means reduction has taken place. And now we are considering H2. See, H2 in this side and this side we have H2O. So that means oxidation, oxygen is getting attached. So that means it is the oxidation is occurring, right? Now we're coming to the point which is an oxidizing agent and which is a reducing agent. So the substance which is getting reduced act as oxidizing agent, because if it is not present, then there will be no source of oxygen. Like in this case, copper is providing oxygen to the hydrogen. That means it is oxidizing hydrogen. It was the source of oxygen. That is why it is providing oxygen to the hydrogen, and hydrogen is getting this thing oxidized. So as the name suggests, reduction, the substance which is undergoing reduction is said to be an oxidizing agent. It is oxidizing the other and in return it is getting reduced. Similarly, the substance which is undergoing the oxidation is called as reducing agent. It is reducing the other substance and in return it is getting oxidized. So this I've told you is a redox reaction. So that means redox reaction is completely based on oxidation and reduction. Now you are familiar with oxidation and reduction, the classical concept, the electronic concept. You know how to indicate oxidation and reduction in case of redox reaction, and you can easily judge or point out the oxidizing agent and the reducing agent as well. So this whole explains the redox reaction. Can you give me two examples? Now you are all thorough with the redox reaction. Can you give me any 2-3 examples in daily life which you come across and that are considered as redox reactions? I think it must be striking your mind. There are few redox reactions which we are occurring in daily life, out of which the two important redox reactions are the corrosion, that is the eating away of metal article due to certain gases, poisonous gases, or when they are exposed to the atmosphere, the gases which are present in the atmosphere. So that means the corrosion, I am telling you, is an example of redox reaction which we come across daily life. And the second reaction is rancidity. What is it exactly? Rancidity means the oxidation of food, means the food you are using, like if you cook something today and tomorrow you will see that it gets stale. It is not fit for this thing eating purpose. It start emitting the foul smell and it start looking, it doesn't look fresh, it start looking stale and it start producing the foul smell. So that means it is a rancidity. The food material which is present, when it comes in contact with oxygen, it gets rancid. That means it becomes unfit for eating purpose, and as a result it start emitting a foul smell, and even the taste gets you can taste also changed, and it is not fit for eating purpose. So this is all, and likewise we have few more examples for redox reaction. This will be taking up in the next units. So for now you should know that what actually the redox reaction is, what a type of chemical reaction we get to see in the redox reaction. So this is the redox reaction which completely explains that how oxidation reduction occur and how it can be used, or how the oxidizing agent act and how the reducing agent get affected. So this is how we come across the different you can say the reducing agent or oxidizing agent, and you can easily formulate the redox reaction as well.